Hello, this is Mrs. Huntley. This is Module 6, Lesson 4. You should be on page 17 of your packet, and it's problem solving with trend lines. You're going to need a calculator handy and some colors for this lesson. Now, the colors aren't mandatory, but I'm going to have you marking some text, and I like to color code things, and I know some of you guys do as well. So if you don't have colors, you can make do without it, but you definitely will need a calculator, or some of you at least will. So let's jump right in. Problem solving with trend lines. Several members at a gym were asked how many minutes they worked out at the gym a day, as well as how many calories they burned. Their answers were used to make the scatter plot at the right. So they made the scatter plot for us, and the x, the independent variable, is our time, and the dependent variable, the y, is the calories burned. So what this table is telling us is the calories burned are dependent on the time. Calories burned would be our dependent variable, time would be our independent variable. Okay, how do we, part A says, write an equation for the trend line. So I need to figure out, first of all, it's going to be in slope-intercept form, y equals mx plus b. So I need to figure out my b. It's crossing the y-intercept at 0, because we're counting by hundredths, and it's hitting right below. So my b is going to be 0. And now I need to figure out my slope, my rise and my run. So I need to find points on my trend line that are also integer coordinates. Now the first one I see also happens to be a data point. It's right here at 300, or at, let's see what that would be, 20 comma 300. My x is 20, my y would be 300. Now there's another integer coordinate right here at 40 comma 600. At this point, I have some choices on how to find the slope. I could use the points and do the Larkin L and figure out that way, or I could count my rise over my run. Now, if you're counting rise over run, be careful. You might think that it's 3 over 2, but we have to look at the graph and see that they're counting by hundredths. So that would actually be 300 over, and then when I go to the right, it's counting by tens over 20. So 300 over 20 would be my slope here. If I reduce the slope, I could grab my calculator right now and do 300 divided by 20, and that's going to give me 15. I could also, if I'm not using a calculator, I could reduce this in my head, saying they both end in 0, so I can divide by 10 there, and then I've got 30 divided by 2, and I know that right off the top of my head is 15. So either way, whether you're doing mental math or whether you're using a calculator, it really doesn't matter to me. So writing an equation for the trend line. Again, I'm going to use my y equals mx plus b, but instead of m and instead of b, I'm going to put in the values that I learned, or the values that I calculated. So y equals 15x. Now I can add the plus 0, or I could just leave it as y equals 15x. So let's think about this. In terms of the equation and the scenario, what is my x representing in the equation? X represents the time, the number of minutes worked out. So I can plug in any time that I'm working out and figure out the calories burned, and that's what the y represents, the total calories burned. So again, I can plug in any x, and using this equation, the y should fall on this line. I hope that makes sense. And we can actually even try it. Why don't we put in 30? Y equals 15 times 30. So grab your calculator. 15 times 30 is 450. So let's follow this up. Does that make sense here? Yeah, it's about halfway between 400 and 500, so that would make sense at about 450. And I can use this to estimate how many calories I'm going to burn at any different time interval if I'm using this type of workout program. So let's do that. How many calories would you expect to someone to burn if they spent 120 minutes at the gym? So, okay, minutes is our x. So instead of x, I'm going to put 120 minutes. So this would be y equals 15 times 120. So grab your calculator. 15 times 120 is going to be 1,800 calories. Let's see. Does that make sense? At 120, I am off the chart here. And when you're off the chart, when you are making a calculation based on something that's not within your data, that's called extrapolation. It's extrapolation. It's extra information based on something that's not even on your trend chart. Now, what we were doing when we said at 30, it would be about 450. That was called interpolation because it's inside the data that we have. Okay, so the next one. If someone burned 1,740 calories, now calories, I should have color-coded this. So this is our calories, that's our Y. How many minutes at the gym would you expect, how many minutes would you predict they have spent at the gym? So we're going to use the same equation, but we're going to plug in 1,740 for our Y, and that's going to equal 15x. Now I want to get the x by itself, so I'm going to divide both sides by 15. Use your calculator. And when I have 1,740 divided by 15, I get 116 minutes. Number 3 says, what is the slope of the trend line? What is the slope of the trend line, and what does it represent? So our slope, hopefully you're recognizing it right off the bat. The slope is 15. It represents the number of calories, oops, the number of calories burned every minute when people were working out. Okay. What is the y-intercept of the trend line of the equation, and what does it represent? The trend line is, or excuse me, the y-intercept is 0, and that means at 0 minutes, people burned 0 calories. Now that's not exactly accurate because our body uses calories just to keep us alive, but I guess that would be extra calories that wouldn't be attributed to the workout. Hopefully that makes sense. All right, let's take a look at the next scenario. Julian made a scatter plot to show the number of band members at his school over the years. The trend line of this scatter plot had an equation of y equals 13x plus 45, where y represents the total number of band members and x represents the number of years since 1990. So how many students would you predict to be members of the band in 1997? So they're giving us our a time. Okay, so I'm going to stay in red here. This is a year. So this says 1990. So to figure out the number of years since 1990, I'm going to subtract 1997 minus 1990. That's 7 years. So my x is going to be 7 years here. So I'm going to take my equation that they gave us, y equals 13x plus 45, and plug that value in. 13 times 7 plus 45. Grab your calculator. 13 times 7 plus 45 is 136 members. How many students would you expect to be members in 2010? So again, they're giving us a date, and I've got to figure out the number of years between 2010 and 1990. So 2010 minus 1990, that's going to be 20. What I'd like you to do right now is pause the video, set up the equation just like we did, so our x here is going to be 20, solve it, and then unpause the video to see if you've got it right. Okay, so when I do that calculation, I get 305 members. Now the next one is a little bit different. It says, in what year would you expect the band to have 370 members? So they're giving us our y, and we have to solve for our x. So 370 equals 13 times x plus 45. This will be a two-step equation. So I'm going to subtract 45 from both sides of the equation. 370 minus 45. Grab your calculator and plug it in. Is 325. Now I need the x by itself, so I'm going to divide by 13, and I get 25. So the number of years is 25. Now that's not what they're asking us. They're asking us in what year. So what I have to do is take 1990, because that's the year that this started up here, 1990 plus 25, and that's going to give me, let's see, that's 2015. So in 2015, I would expect the band to have 370 members. Okay, let's move on to the next page. In 1960, about 45% of the U.S. population smoked cigarettes. The percentage of the U.S. population that smoked cigarettes over the years since 1990 is shown in the scatter plot. Okay, so our y-intercept is 45% because this is the percentage of the population. The years they're saying is the independent, and what changes is the percentage based on the year. Okay, so x is our independent variable, y is our dependent variable. It's telling us they're starting at 45%, so I know my b is 45. I have to figure out my slope. I know it's going to be a negative slope because the line is going down and to the right. So now I need to find another place where this line is crossing integer coordinates. And it looks like the next place is right here. My x is 40. My y is 20. And I'm going to count rise and run. Now notice that I'm going by tens here. So I'm going down. Let's see, 5, 15, 25. And then I'm going over, also counting by tens, 10, 20, 30, 40. Now 25 and 40 are both going to be divisible by 5. 25 divided by 5 is going to be 5. And 40 divided by 5 is going to be 8. So my slope is going to be negative 5/8. So if I'm writing this equation, it's going to be y equals negative 5/8 x plus 45. What does the x represent in the equation? The number of years since 1960. Okay, so the x, this is 1960 right here, 1970, 1980, 1990, 2000, 2010, 2020, etc. Okay, this is the number of years since 1960. So you're counting by tens, by decades. What does the y represent? The y is the percentage of the U.S. population that smokes cigarettes. Okay, so it started at 45% and it's been going down since then. So what does the slope represent in the context of the situation? That means in this problem, what is negative 5/8 representing? And that is representing The percentage of people who smoke cigarettes decreases about 5% every 8 years. This is my percentage over my years, 5% in 8 years. Okay, what does the y-intercept represent in the context of the situation? In 1960, 45% of the U.S. population smoked cigarettes. That was given to us in the problem. The next one says, in what year would you expect 5% of the U.S. population to smoke cigarettes? So let's take a look at this here. The percentages is our y's, and we should have color-coded this. And that's our y. And the number of years, oops, I meant to change colors there and it didn't work. Number of years since 1960, and that's our x. So they're giving us a percent here at 5, that's our y. So we're going to plug that into our equation. 5 equals negative 5/8 x plus 45. Again, it's a two-step equation, so I'm going to subtract 45 from both sides. Told you equations do not go away. They were going to be with you forever. Negative 40 equals negative 5/8 x. Now, when you're dividing by a fraction, remember you multiply by the reciprocal. I know you can use your calculator, and as long as you're confident that you're plugging everything in right, that's fine. I'm old school, so I'm going to multiply by the reciprocal and plug it into my calculator as negative 8 times negative 40 divided by 5, and my answer is going to be 64 years. It's asking us, though, in what year? So I need to start with 1960 and add 64 years. So it's going to be 4 to 2024. So in 2024, that's within our lifetime, we would expect about 5% of the population, only about 5% of the population to still be smoking cigarettes. Okay. In 2016, so we're still dealing with our years, about what percentage of the U.S. population do you expect to smoke cigarettes? So I need to figure out the difference between 2016 and 1960. Grab your calculator, 2016 minus 1960. That's going to be 56 years. Oh, I'm sorry, they're giving us a year here. I should switch to green. Okay. So that's 56 years. That's my x. So I'm going to say y equals negative 5/8 times 56 plus 45. Again, grab your calculator. Negative 5/8 plus 56, that's negative 35 plus 45. So y equals 10. So about 10%. Okay. So I'm running at 18 minutes right now, and the bell is going to ring shortly. So I'm going to end it here, and we will do the last example. Actually, if you can, work on the last example and see if you can figure out how to do 12, 13, and 14. A scatter plot was created to show the temperature based on the altitude above sea level. The equation for the scatter plot's trend line is y equals negative 0.0035x plus 49, where y represents the temperature. So let's do y is green, y represents the temperature, and x represents the distance above sea level in feet. Use the equation to answer the questions below. So see if you can work through 12 to 14 before you come to class tomorrow. And just remember, we're using slope-intercept form, we're solving equations, and we're using the data to make predictions about what's happening at different points within the graph that we don't have a data point on, or even outside the graph. Interpolate inside, extrapolate outside. No, you won't be responsible for those vocabulary words, but I like incorporating in academic language anywhere I can. Have a good night. See you tomorrow.